Hi everyone, my name is Kirill, and in today's tutorial I'm going to show you how to insert external assets into our game, War Thunder. First, we start 3D Max. Detailed installation instructions for 3D Max plugins can be found on our website. Once installed, they show up right here in the Utilities tab. They show as Dagor Font Export, Dagor Scene Export, and Dagor Utility. I will explain the way they all work in more detail later. As an example, we have this bridge. It is a draft model on the basis of which a clean one will be made for subsequent insertions into the game. The most important thing to know about this model is that it's made to proper scale. For example, its dimensions are roughly the same as that of a real-world bridge. This will help you significantly in the future because our locations all feature realistic dimensions. And if you were to insert it into a poorly scaled model, it would be either too small or too large. Then you're going to need to rescale it, and it may result in bugs. I recommend using meters for sizing and measuring. As you can see, on this model, we have simple, standard max materials that use diffuses and normal maps. In order to use this model in the game, you need to use our materials, and that means the textures need to be moved into the game's folder. I recommend creating an extra folder under Develop, Assets, Entities, containing your models. And then another subfolder for each specific model, such as for the bridge. Let's move the diffuses and the normal maps there. Let me show you what's inside. This is the bridge's diffuse. Note that it lacks an alpha channel because transparency isn't used. This is the bridge's normal map. Note that it has an alpha channel and a specular map inside. We store the specular map in the normal map's alpha channel. That way, we don't need to create a separate texture. Here's the texture for the fence with an alpha channel that contains transparency. Now we need to set the right materials. The easiest way is to pick material from an object. We'll get a submaterial with two materials because we use two different textures with different properties. And each of these materials needs to be reassigned to Dagor Dagorat material. We select Shader from the class folder. We have many shaders. The main thing you need to know is that our shaders are divided into dynamic and static. Dynamic shaders are used for dynamic models. Dynamic shaders are used for dynamic models. For example, for models set from Mission Editor. That includes all aircraft, tanks and ships, vehicles, and other moving objects. Everything that isn't dynamic is static. Our dynamic shaders are marked with the word dynamic, whereas the static ones aren't. Our most standard shader is called Simple Aces. It can do anything we wish, so that's what we're going to use. I recommend placing the texture right in the game's folder. This is the diffuse, and this is the normal map. We don't need any of the extra parameters, but if you find yourself in need of them, they're pretty self-explanatory. Ambient, specular map, diffuse, they can all be set. We'll talk about the two-sided parameter later. By default, the object's lighting is turned off, as it should be. If you want to use a custom light map or vertex lighting, then you need to flip this switch. The fence is a little more complicated since it has an alpha channel. For the diffuse, we set the same texture. But we also have to add the alpha test parameter and set its value at 127. Why 127? This is the threshold at which the material is considered transparent. 127 is exactly half of the alpha channel's dynamic range. In other words, half of 256 colors. So, here's our bridge, which we can already export. To do this, we need to launch Dagor Scene Export. By default, the Dagor Scene Export utility looks like this. This Cell, Selected button is important. It decides whether to export the entire scene or only the selected object. In this case, we need to export only the selected object. I'll explain why a little later. We select our object, press Export DAG, and select the folder to export it to. We press Export and see that our object has appeared in the folder. Everything should work by default. Let's launch Asset Viewer and see if we did everything properly. And indeed, our folder has appeared in Asset Viewer. Here it is: Entities, User Assets, Example Bridge. Here we see our textures and the model itself. So the model works. But as we can see, the fence is only visible from one side. Why is that? In 3D Max, our fence was modeled simply as plane with a texture and transparency. As we can see, this plane is one-sided. There are two ways to solve this problem. Either make another plane, or indicate in the shader's properties that the plane is two-sided. To do this, we go to the fence's shader and set it to two-sided. If we just set it to two-sided, then it will mirror the texture on both sides. But if we set it to two-sided real, then the shader will render another polygon with the same texture. In some cases, we're going to need two-sided real, but in this case, two-sided will do the trick. Now, let's export and save it over our model. Note that our model doesn't update immediately in Asset Viewer. We have to switch to another prefab. Of course, we could close and reopen the program, but it's faster to switch to another prefab and then switch back again. The model is now visible from both sides, like this. Everything appears to work, and we can import this model into the game. But first, I want to show you one more thing. As you can see, we now have a prefab. There are only two types of models in the game: prefab, from prefabricated, and rendinst, from render instance. We have a prefab here, as indicated by a blue trapezoid icon. How do prefab models differ from rendinst models? There are two fundamental differences. Prefabs have no loads, levels of detail, and prefabs can't be placed along splines, land classes, and so on. Since you can manually place both prefab models and rendinst models, I'll just show you how to make a rendinst. First, we close Asset Viewer because it can't automatically load new models. What this means is, if you exported a new model which Asset Viewer didn't know about when it was launched, it won't see it until you relaunch it. Note that I actually had two objects in this scene. Apart from the ordinary bridge, there is also this one, a simplified model with no fence and somewhat fewer polygons. Let's take the bridge material from our submaterial and assign it to our simplified model. Is the name important? No, it isn't. You can name your model whatever you like. This is simply a mesh name. The main thing is for the name not to have any non-English symbols. Of course, it's best to use some kind of logic in naming your models. Next, we have two ways of loading the right model. The first method is to do it by hand. It should be obvious how this is done. First, we select the larger model, the one with more detail. We delete this DAG file since the model can't be both a prefab and a Rendon at the same time. Therefore, we have to delete the standard DAG file and create a file with the load00 sub-extension. This will be our 0-point load, or the highest quality load, and this model will be load01. The Dagor utility is warning us that the exported scene contains degenerate triangles. What does that mean? It means that there was an error when the mesh was being created. We could remodel it from the beginning, but that's a poor option and it would take too much time. We have a utility which can deal with this. The Dagor utility contains many interesting tools. Dig around yourself. You'll find many useful things which are pretty much self-explanatory. There's a utility for converting materials into Dagor materials and back again. One for transferring UV coordinates from one channel to another, one for working with splines, and a scatter utility. In this case, we need the Remove Degenerates utility. A caveat of this utility is that it only works with an editable mesh. So, we convert the object into an editable mesh and launch Remove Degenerates. We can see that the utility has removed something. Now we press Scene Export again. Note that although it showed an error, the file was still saved with the bug. This is worth noting because the file may not work later in the game if it contains a bug. If you get an error, resave to make sure no bugs are introduced. Now, let's relaunch Asset Viewer. We now see that the model's icon has changed. And here we see that it is no longer a prefab, but a Rendon. It also has loads with the distances indicated in the initial BLK file. We can switch through the loads manually and see the different levels of detail. We can also simply zoom out, and at a certain distance it will change automatically. The difference is pretty noticeable. I didn't make this model very carefully, but it's good enough as an example. The problem here is that I didn't set the smoothing groups properly. Speaking of smoothing groups, let's correct this one, and I'll show you something important in the process. In our engine, it's important for each polygon to have a smoothing group. If it doesn't have one, well, let's see what happens. I turned off a smoothing group for one polygon. Now, if we try to export it, we get an error that we have triangles without smoothing. These triangles won't work, so I recommend automatically smoothing your model. Now the transition should be better. Let's export the model. Unlike prefabs, Rendon models refresh straight away. So here we have the updated model. The difference should be less noticeable now, but let's see. Now, we're always going to have Load 1 turned on. The distance might be a little too short. The load might not have been done perfectly. Anyway, the model is ready. What next? Next, we just import it into the game. To do this, we launch Location Editor. I'll open a location I made earlier. We unpress the snaps, press Create Entity, and find our bridge in the list of assets. As we can see, it's open from two sides, as it's intended to connect the banks of a river. So, we'll just put it where there's a river. Evidently, it's set to Place on Collision. But we can just uncheck that. I want to note one especially important point. Regardless of the fact that your resource is now in the editor, the game knows nothing about it yet. For the game to find out about it, the resource needs to be exported. How do we do this? We can select the resource we need and command to export it. But it's better to export everything at once with the Export All command. We wait for this to happen, and now the resource has been exported into the GRP file with user resources where the game can access it. After the resource is exported, and after you export the level, your resource, your asset, will appear on the location. As I said before, there's another way. We can export Rendon models more efficiently. This method is more convenient when you need to export several Rendon models in a row, or when your Rendon consists of several nodes. I'll show you this method now. It's based on layers. Here, I have a certain layer called Stronghold. We move all the objects from it into the 0 layer. Rename the layer itself to Load 00, and create a layer named Load 01. Now, we need to move the object belonging to Load 0 onto Load 0, and the object belonging to Load 1 onto Load 01. And now, if we launch Dagor Scene Export and unset the cell button, it will mean that our entire scene will be exported into the Dagor file. The layers will be automatically exported into the loads. What is the result? Please make sure that there's nothing extra in your scene when you have the cell button unset. This is because if you have some hidden object far away or invisible objects in other layers, these objects will also be exported into the DAG file. You'll see these objects in the game and wonder where they came from. So, we export to Load 0. We then see a message that the loads have been found and asking whether they should overwrite the others. We confirm, and now we're done. Next, we repeat the process. Simply launch our asset viewer and export the resources. Now, let's try to create our new land class. I have a texture here made for this purpose, with no alpha channel, as we can see, and seamless. The size is 2048 by 2048 pixels. We save it under Land Classes. Note that although we have a folder called Land Classes containing all the land classes used in the game, we can't save our land classes here because this folder doesn't export and therefore won't make it into the game. This is why I created a separate folder called User Land Classes. In it, You can create your own subfolder structure. You can even rename the folder. We'll save our texture here and call it Test Sand Land Class Tex. We save it as a 24-bit file, as it has no alpha channel, and now we also need to create a BLK file describing this texture's mapping and other characteristics. It should have the same name, but with a land BLK extension. For now, let's delete all that. We can take a look at the land class structure in any other land class. Let's look at the African land class, for example. So, class name sets the land class. Next, we've got detailed texture and object generate. This generates objects according to a mask or some other method. We can just copy this part. If the line starts with a double slash, it is a comment. If a line starts with a slash and an asterisk, the comment continues until the asterisk and slash symbols. Let's correct its dimensions to 2048. Next, let's change the texture title. Now, we save changes and exit. This is now a basic land class without any object generation. Since our asset viewer doesn't detect objects created in the process of its launch, we have to restart it. The same goes for our location editor. It too doesn't detect the land classes created the moment it was launched. We launch our asset viewer, and there's our land class, which in this case is a texture mapped on 2048 by 2048 meters. That is, we don't have any additionally generated objects here. Let's set up some object generation while we're at it. To do this, we open our diffuse and make a mask from which our objects will be generated. Since this is a desert, it's logical for bushes to grow only where the sun doesn't shine as much, the shade. So, this is what we'll do. Now, we have a mask which we'll consider our bush growing mask. We save it next to our land class. We can use the TIFF format for this, making it not a texture, but a grass mask. Now we'll use a BLK file located in CDK Develop Assets User Land Classes. Here we have to write the object generation scheme. Let's see how this is done in other land classes. Say, in Tunisia. I'll just copy the whole section from here. Let's remove the comments and change the density for this texture. Now, let's correct the size to 2048 by 2048. This is how it works. This block defines the objects to be generated. Place on collision tells us that the objects will be placed on collision and not just float in the air. This is the density of our objects. The intersection line indicates their overlap. Random seed is simply the number that sets the randomness of our generated objects. Color from and color to define the range of colors our objects will use. We need this to make sure all our objects are colored in a way that suits our own land class. In this case, the generated objects are oaks. We can see that in the object's name. This isn't really what we want, so let's open Asset Viewer and find some bushes to use. All of our vegetation is in the Vegetation tab. Here, we have a so-called African dead bush, designated Afar Dead Bush A and Afar Dead Bush B. These two bushes should be enough for us. Let's move on to the Lair Generation. We remove the extra objects as we've already decided we only need 2. The objects we'll be generating are called Afar Dead Bush A and Afar Dead Bush B. Now, let's see which generation properties each object has. Each object has a weight. Weight defines the object's value. The higher the weight, the more of these objects will be generated. Additionally, each object has rotation and scale parameters. Rotation is set separately for each of the 3 axes. The first number is the Rendoned object's initial position. The second number is its delta, meaning how far this Rendon can rotate. This means that each copy of this Rendon can rotate from between 0 and 3 degrees on the x-axis, between 0 and 90 degrees on the y-axis, and between 0 and 3 degrees on the z-axis. Our y-axis looks up. It's the object's rotation around itself. As for the x and z-axis, these show the inclination of our future bushes. Scaling is currently set at the same. 0.25 is the bush's initial scale from the general one. That is our delta. I don't think we need this level of extreme scaling, so let's make it a little closer to the original scale of the bush model. That's what we'll do with the second bush. Let's make it a little different. Now, we save our land class, exit, and launch Asset Viewer to make sure we've done everything correctly, and that there are bushes growing on our land class. We examine our land class. Everything looks okay, but the density seems a little higher than in real life. You don't see so many bushes in the desert. Therefore, let's go back to our land class and make the overall object density around 20 times lower. And now we can see that the density has been reduced. The land class is basically ready to be imported into the game. But before we do that, let me tell you how splines are created. As we can see, the spline class consists of the spline itself and a material. And every material needs a texture. We'll do it all in reverse. First, I have this texture prepared. We'll save it to our War Thunder CDK Develop, Assets, Splines, and Lands folder. I'll create a new folder here for our splines, and we'll name it Splines, for example. Note that this is a 32-bit TGA file with an alpha channel. The alpha channel contains this texture. The alpha channel explains how our texture fades into transparency. The white parts will be opaque, and the black parts, accordingly, will be transparent. This is roughly what it will look like if emulated in Photoshop. Now, let's save our existing material into the folder with our already existing spline. We will, of course, rename the material and indicate the correct texture in it. For several reasons, we need to indicate it here 3 times. The Text 1 tab indicates a detailed texture. In this case, we have detailed sand, which is clearly suitable for our purposes. Let's go through the parameters of the material itself. To repeat, class name indicates which shader we're using. In this case, Land, Mesh, Combined, Detailed, Decal, which also already has a certain detailed texture. Script indicates that the detail structure is tiled in 8 by 2 meters with no offset. In other words, we can set the offset in these parameters. In our spline class, the alpha channel also acts as a height texture, and the height above parameter, accordingly, tells us how this alpha channel is to be interpreted. If height above is equal to 0, the texture is considered to be sagging. For example, more white means lower. If height above is equal to 1, the texture is considered to be protruding, which is to say, our road will be a little higher than the rest of the landscape. The alpha threshold parameter tells us when our alpha channel becomes transparent. In other words, if we make the sides of the alpha channel gray, should that be considered transparent or not? As we know, 150 is enough here. Later, in the editor, the Vertex Opacity parameter allows our spline to possess vertex transparency. That means that in each vertex, we can now indicate how transparent this spline should be. This is a very important parameter because it means that the ends of the spline can fade into complete transparency, which creates a natural transition between the spline and the landscape. Below, we just have the textures. So, we're done with the spline now that we have set the right texture name. Only, it's not totally right, since ours has text. Let's fix it. Rename our spline and take a peek inside. Class name tells us that this is a spline class. Here, we just set a name for our spline class, but we can write here whatever we like. Let's just call it Sand Example Road. This is the name it will have in the editor. Here's the name of the material. The subdiv count and shape subdiv count parameters edit how accurately the drawn texture will render the spline's curve. Essentially, these parameters are perfectly suitable for our road. The flip UV parameter allows us to flip the UV coordinates for our spline class, which is sometimes necessary. The V-tile parameter defines how many times the texture will be extended vertically. Right now, it'll be extended vertically once. We can set it at 2 or 3 to get a double or triple road. And the U-tile parameter defines how many meters it will extend horizontally, like this. $1,100 is probably a little high, so let's set it at 110. I think that should be enough. Extrude defines whether we want our texture to extrude. In this case, we don't. Cull CW defines whether we want to draw it in reverse, and Offset tells us whether offsetting the texture is necessary. The following parameters are for cases when our loft is rendered. In our case, it will be baked into the landscape and not rendered, so we'll just delete everything. And here's the flag that decides whether our spline will be rendered. For example, renderable, B equals yes, and collidable, B equals no. In other words, it won't create any geometry. It'll just create the texture which will bake in our land mesh. The shape parameter contains the dimensions our texture will tile and map to. I'll show you what this looks like later in the editor. For now, we'll just leave them alone. The other shape parameter is only required if we have collision, so we can delete it too. Next, we have the colliders parameter, which we'll need if we want to generate objects. Of course, we will want to generate objects, so we'll come back to it later. For now, I'll tell you how sweep width works. This is the parameter responsible for whether the spline will delete rendinsts around it. What is this good for? Well, since we're drawing a road and it might go through a forest, it could turn out that we'll have a tree standing right in the middle of the road. If we want to avoid this, we can set a radius in meters here, the distance from the center of our spline outwards, in which the spline will delete rendinsts. Actually, 50 meters is a bit much. Let's set it at 20. Since we want to generate objects, let's look at a spline which does so. Here we have a spline with Object Generate. Let's copy this Object Generate block and insert it into our spline. There really are many objects here. I'll leave one. That should be enough. The Object Generate parameter works a little bit differently from the one in the land class and requires additional clarification. These two parameters, place at start and place at end, indicate whether we need to generate objects right at the beginning or right at the end of the spline. In some instances, like when your roads end at bridges, it's best to set this to no. The place above HT parameter defines the height at which your objects will hit a collision. The more curved your landscape, the higher the value you should set, but 100 meters should be plenty in our case. The colliders parameter indicates the geometry your generated object should be placed on. In our case, this will be the height map, prefabs, additional map geometry, and the geometry the spline generates. Random seed is a random number that you can change and thus increase the randomness of your generated objects. Step defines the periodic interval at which our objects will be generated. Color from and color to work the same as in the land class, which is to say that they color objects within a certain defined range. Orientation fence defines how objects will be oriented in relation to the spline class. We have orientation fence and orientation world. With orientation fence, objects will be placed along the spline class and will be oriented perpendicular to landscape. And with world, they'll all be placed identically. This will be simpler to show in the editor. Here, we have the name of the object to be placed and its overall generation weight. If there were several objects, the weight of each of them would be important. And then, rotation and offset. Offset offsets the object relative to the spline's 0 point. You can also see how this works in the editor. Since we've basically done everything, let's launch our asset viewer. Now, let's build the resources so we can import them into the editor. Here's our folder. Not yet built, and our spline class inside it. Since the editor doesn't show spline classes, all we can see is the texture. The texture with the alpha channel, which means it works. We export our resources. After the export is finished, we can close our asset viewer, saving the asset base in the process, and launch the location editor. Here's our location. First, let's test our land class by trying to set it as the very first land class. For example, User Land Classes, Test Sand Land Class. Well, we have sand and we have bushes. Some of them are floating in mid-air, which just means we need to rebuild the land mesh. Let's try drawing another spline class. There. As we can see, it's very wide, clearly wider than a road should be. To fix this, we just go into the spline and edit the shape parameter. While we're here, I'll show you what this parameter affects. Shape contains points, with each of the points representing a distance from the spline's curve. The first coordinate in a horizontal direction and the second in a vertical direction. The second parameter is our textures mapping. Since our road is simple, all we need is 2 points, so we can delete the third. At an identical distance from the center, we can set this one at 0, since we don't want anything going underground. I'm thinking -10 to 10. Which should make it a 20-meter road. It might even be a little much, so let's make it -7 to 7. And we'll indicate here on the mapping that it will map from 0 to 1. We won't touch the second coordinates. You'd use this if you wanted to make some kind of crooked UV mapping. You can try changing it and see how it affects your spline class. Now, we save our spline and go to the editor. Also, while we're here, I'll show you how Vertex Opacity works. Vertex Opacity adds this slider, which you can use to simply edit the transparency. That's it. If you export this level to the game using Project Export to Game, you'll have a working level featuring the assets you included: a bridge, road, and land class. As you can see, it isn't rocket science. Give it a shot, good luck, and don't forget to subscribe to our channel. There'll be lots more interesting stuff coming up. Thanks for watching.